sounds.
Hi guys, this is Baker Timpla and welcome to my vlog. Let us start now to discuss about the geological works by wind. So what is wind? Well, air in motion is called wind. Wind is one of the three major agents of change on the surface of the earth, and the other is the river and glaciers.
Wind acts as agent of erosion, as a carrier for transporting particles and grain so eroded from one place and also for depositing huge quantities of such wind-blown material at different places. And there are three modes of activities. First is erosion, second transportation, and last is deposition by wind.
Now let's talk first about the wind erosion. By the way guys, what is the meaning of wind erosion?
Wind erosion is a natural process that moves soil from one location to another by wind power.
So therefore, ang natural na proseso ng paglipat ng soil sa isang lokasyon patungo sa ibang lokasyon dulot ng hangin ay tinatawag na wind erosion. And now, let's proceed to the first method of wind erosion, and that is the deflation. Wind possesses not much erosive power over rocks the ground cover with vegetation. But when moving with sufficient velocity over dry and lost sand, it can remove or sweep away huge quantity of the lost material from the surface. And this process removal of particle of dust and sand by strong wind is called deflation.
So therefore, ang proseso ng pagkatanggal ng mga maliliit na butil ng alikabok at ng buhangin dulot ng malakas na hangin ay tinatawag na deflation.
And the second is wind abrasion. Wind becomes a powerful agent for rubbing and abrading the rock's surface when naturally loaded with sand and dust particles. And this type of erosion involving rubbing, grinding, polishing the rock surface by any natural agent is termed as abrasion.
So ang erosion na nag-i-involve ng pagkagasgas, paggiling at pagkapalis ng mga bato dulot ng hangin ay tinatawag na wind abrasion.
And the last is attrition by wind. The sand particles and other particles lifted by the wind from different places are carried away to considerable distances.
The rock particles not only abrade the exposed bedrock but they themselves are also abraded by colliding against one another. This produces a rounded appearance of individual fragments.
Now let's talk about the sedimentation transport by wind. Sources of sediments. Wind is an active agent of sediment transport in nature. Materials of fine particle size, such as clay, silt, and sand occurring on surface of the earth are transported in huge volumes from one place to another in different regions of the world. Methods of transport. The wind transport is carried out mainly by two distinctly different processes that are suspension and siltation. Suspension is when the light density clay and silt particles may be lifted by the wind from the ground and are carried high up to the upper layer of the wind where they move along with the wind. Siltation when the heavier and coarse sediments such as sand grains, pebbles, and gravels are lifted up periodically during high velocity wind only for short distance. They may be dropped and picked up again and again during the transport process. Siltation is therefore a process of sedimentation transport in a series of jumps. The transport power of wind. The transporting power of wind depends on its velocity as also on the size, shape, and density of the particles. The amount of fluid already present in the wind at a given point of time also determines its capacity to take up further load. And lastly, we will discuss the last mode of activities of wind, which is the deposition by wind aeolian deposit. Sediments and particles, once picked up by the wind from any source on the surface, are carried forward for varying distance depending on the carrying capacity of the wind. Wherever and whenever the velocity of wind suffers a check from one reason or another, a part or whole of the wind load is deposited at that place. These wind-made deposits may ultimately take the shape of landforms that are commonly referred as aeolian deposits. These are two main types of deposits: dunes and loess. Dunes. These are variously shaped deposits of sand-grade particles accumulated by wind. A typical sand dune is defined as a broad conical heap. A dune is normally developed when a sand-laden wind comes across some obstruction. The obstruction causes some check in the velocity of the wind, which is to drop some load over, against, or along the obstruction. When the process is continued for a long time, the accumulated sand takes the shape of mound or a ridge. A typical dune is characterized with a gentle windward side and steep leeward slope. Loess. The term loess is used for wind-blown deposits of silt and clay-grid particles. Typically, loess is unconsolidated, unstratified, and porous accumulation of particles. Strong winds blowing over very extensive area of deserts, outwash plains, and soil loosened by fluff pick up vast amount of fine-grained particles for transportation in suspension. When such dust-laden winds passing over steppes and other flat surfaces are intercepted by precipitation, they drop their entire loads on the surface below. This process is repeated for years. Accumulation of such sediments over years have resulted in the present loess deposits. So guys, we're done discussing about the geological works by wind. And now let's proceed the engineering importance of wind. So let's go.
Wind power plant. In this session, we will define wind energy, study the working principle of wind power plant, and learn the application of a wind power plant. Wind energy. Wind energy is the form of solar energy which is produced because of the uneven heating of the earth by the sun. Wind energy is renewable energy and it helps to keep the environment clean. Wind energy can be used for sailing, grinding grains, electricity generation, etc. Let us study the working principle of wind power plant. The important job of converting wind energy into electrical energy is done by the wind turbine of a wind power plant. Let's see how. Unlike the fans, turbines use the wind and generate electricity. The hub and blades are called turbine or rotor. Behind the turbine, there is an engine house called as nacelle. The nacelle is mounted on a tower in order to get more wind energy. The wind will cause the blades to rotate. Due to this, the rotor starts moving. As the rotor is connected to the main shaft, it spins the generator, because of which electricity is produced. This electricity can then be transferred by using transmission or distribution lines to homes, industries, schools, hospitals, etc. Let us study the parts of the wind turbine. Let us start with the blades. Wind power plant may consist of 2 to 3 blades. The wind will cause the blades to rotate, which in turn will rotate the generator. Next is shaft. The hub is mounted on the main shaft. The rotation of the blade causes the shaft to rotate. If the wind blows very fast, then brakes can be applied to control the speed of blades and shaft. Next is the gearbox. This can be used to increase the output speed. Next is generator. The high-speed rotating shaft is connected to the generator. Because of this, generator rotates and electricity is produced. This electricity can be stored in batteries and can be used whenever necessary. Applications of wind power plant. The application of wind power plant is to generate electricity. This electricity can be used for many purposes. This electricity can be provided to rural areas where there is a shortage of power supply or no power supply at all. It is easy to establish a wind power plant in rural areas because free wind and space is readily available, and it requires very less infrastructure and cost. In this session, we learned about wind energy, the working principle of a wind power plant. We also studied the applications of wind power plant.